It's good to have you today. And this is Limon from SuperMap Research Institute. And I'm very honored to, on behalf of my colleagues, to share the new features and enhancements in SuperMap GIS 10i 2020. The main highlights in SuperMap GIS 10i 2020 can be summarized as system evolution and technology upgrades. This year, we have the technology system evolution from bit CC to bit DC. The first letter C in red, as we see in the picture, stands for the cloud native. Now, let's take a look at the SuperMap GIS 10i 2020 technology system. And we have Big Data GIS, AI GIS, 3D GIS, cross-platform GIS, and an evolutionary change, which is the distributed GIS for optimizing the performance and the reliability of processing a large amount of spatial data. And in this version, we have 6 key technological upgrades, including technological innovations about the data storage, virtualization, analysis, AI, and processing tools, etc. And the first one I would like to share with you is the highly reliable geo-blockchain technology. As we said before, we upgraded blockchain technology to geo-blockchain technology, which provides high reliable data storage. And just Dr. Song just gave us a very detailed introduction on this point. The second technological upgrade is ARGIS technology based on video spatialized applications. Okay, let's try to imagine such a scenario. If we are in a shopping mall, consists of such a multiple number of floors, especially during our first visit. What bothers us? For me, the problems may be where's the restaurant I would like to go to, and even where am I? Well, that do bother me sometimes. But now things can be changed by using AR visual positioning technology. If we're confronted with such condition, just take out the smartphones, just like what we do in the cars. And the GIS with AR provides the indoor positioning capability with detailed and accurate location information inside buildings, and we could find our position with ease. Given the position information, AR indoor navigation now enables users to navigate indoor environments by providing directions and paths directed through their camera in AR. What we're gonna do is just follow the arrows and we will get where we want. Shopping experience can be also much upgraded by using AR map. In this video, AR map helps to identify the store, and then we may get the latest press information and the related comments from the internet simultaneously. As we all know, data collection is the basis of mapping. This year, we deliver a new method, which is to scan things to collect the feature point cloud in order to draw a map. By using this method, some places hard to access before now can be mapped. During the process of collecting, we can see a set of points is showing on the right, then the map is auto-generated. AR technology can also be used to measure height and area, because as we see in the videos, we can measure the height and the area in public places for the better public management. Nowadays, surveillance cameras are widely used in public places to improve public safety and reduce crime rate. And I think surveillance cameras could bring more convenience for our daily life. What is going to happen when AR is combined with AI? And here's a typical application. We can make geofencing on video from the surveillance cameras. We use AI to recognize the plate of the offending vehicles, and AR is used for the real-time positioning. Integrating AI with AR, vehicles that violate the traffic regulations can be automatically identified and tracked. The third part, we'll be talking about the way in which 3D GIS permeates across different industries by supporting new data type, analytical techniques, and virtualization improvements. And it's very thrilling. We are seeing new areas in which GIS is being approached. And firstly, new data type is supported now. And as we all know, CityGML is an open and international standard for the representation and exchange of 3D city models. Now, CityGML is available to be imported and outported in SuperMap GIS 2020. And most importantly, its relevant geometry, topology, and semantics information will also be kept in our dataset. Triangulated irregular networks, as we say, TINs, are a form of vector-based digital geographic data constructed by triangulating a set of vertices and represent height values across an extent, such as mountain peaks, roads, and so on. And comparing with the grid data model, TINs can have a higher resolution in areas where a surface is highly variable, and it is capable of preserving all the precision we need that we can use to enhance the analysis results with virtualization. We have released many functionalities on TINs since 2007, as 3D GIS is used in the broad swath of industries in recent years, and we optimize the performance for mosaic, excavation, clip, and extraction of Z value from TINs based on the 2D point, line, polygons features. In order to improve the processing efficiency, we could also create TIN from the point dataset and contours with optimized edges. This is a comparison shown on the two pictures. Because of different way of data collecting, as we see in the left picture, some slope protection models, and as we see in the picture, made in the beam designing software are hidden in the TINs, as we outlined by the yellow circles. And after excavation on TINs, the models are perfectly matched. Here's a case. We use the function mosaic to flatten TINs with beam models to improve the overlapping results. Now, TIN is widely applied in transportation projects, which requires a comprehensive set of terrain editing tools that optimize road or rail designs. In this demo, we modify the TINs by the operation I mentioned in previous slides and make the TIN match the road beam data and other kind of data to ensure the flexible designing collaboration. Special query is the common tool in GIS. It's worth to be mentioned that based on GPU, we can get a spatial query results on the fly, so that thousands of the beam components can be queried in a more efficient and interactive manner. As we see in the video, we can query the results by the thousands of components. And it's hard to imagine use CPU to do the same job on the web, right? And in BIM and GIS integration scenarios, more flexible operation experience are needed, then we provide the cross-window section, just like the engineers use in AutoCAD. It will select all elements inside and touching the window, even objects are obstructed. And GPU is also applied in underground 3D GIS applications. This year, we're also having a lot of good improvements in analyzing and virtualizing the 3D geological models. And we provided the real-time profile analysis, real-time cross-sectioning, real-time excavation, and real-time representations includes explosion and vertical exaggerations, and real-time the borehole generation functions. And in this video, we use real-time profile analysis to virtualize the distribution and the composition of the interior geological layers. You can also do sectioning and excavation to observe interior geological structures and find out more characteristics. Expanding the vertical scale is known as vertical exaggeration, and explosion is commonly to use with the vertical exaggeration in order to view the interior structures, such as the faults and the folds inside the geological layers. We click on certain positions to simulate the borehole's drilling, and the results provide us the information about the geological compositions and the distribution under the buildings. And all the relevant information helps to identify geological hazards in advance and for better decision making. Another emphasis I want to put on is the enhanced performance throughout the SuperMap GIS platform has dramatically improved. As we can see in the movies here, and this is an oblique imagery data with a coverage more than 100 square kilometers, and the file size exceeds 400 gigabytes. You noticed it's slowly drawing in the left, and in the right, it immediately draws after combining the root nodes, so that this test indicates that it means the large 3D data such as oblique imagery, point cloud, and man-made models could be viewed more efficiently on web. And recently, we have a talk with our users who have higher expectations for more appealing visual effects. So we are starting to integrate with the popular game engines through i3M. It stands for the Spatial 3D Model and Open Data Format for streaming massive heterogeneous 3D data across platforms. The value of game engines is extended through accessing geospatial data with real geographic coordinates, and the GIS benefits from the realistic and immersive experience provided by the game engines. And we provide the product, the SuperMap Scene SDKs 10i 2020 for the game engines to deliver the cutting-edge interactive experience to our users. The main functions in this product can be characterized as 2 points. The number one is the GIS data virtualization. We can display massive heterogeneous 3D GIS data on the game engines, and they can dynamic access to the local or the SuperMap GIS service data through the net, and we provide the global and the local using experience. The second main function is the GIS analysis and the query, the real-time box clip contour map analysis, and attribute query functions are provided in this product. Unreal Engine is an open and advanced real-time 3D creation tool. We come up with SuperMap Scene SDK for Unreal, this product. And now, Unreal Engine has access to massive beam, man-made model, and oblique imagery, point cloud through S3M data standard. And this is the real-time box clip function provided in the Real Engine. And we can see the interior components inside the building. And this is a demo of simulation on fire emergency. S3M is used to represent the oil plants at the GIS base map. The particle system is created from the Unreal engines for the fire and smoke. It is another good case infiltrates a professional GIS software with game engines. We also developed a plugin for Unity, which is another famous real-time 3D platform. Again, all the commonly used GIS data supported in Unity, as we see in these movies. Also, the real-time box clip functions in Unity. It is quite useful, which is used in the architectural industry. The contour map analysis on DEM now could be used in Unity, and we provide a series of analysis functionalities in SuperMap Scene SDKs for game engines. And we hope the integration of GIS and the game engines may establish a new ecology for the users from both sides. In addition to game engines, there are more compelling 3D effects provided in SuperMap GIS products. We have the ocean with dynamic waves, real-time reflection, shape controls, and the sky and cloud with volumetric cloud, fluid dynamic cloud, and halo. And we have more animated models supported. In this demo, we could see the volumetric cloud floating on the sky, the fast, realistic 3D ocean effect with the dynamic waves and real-time reflection. Using this new experience, we are continuing to seek more areas where 3D GIS has potential to contribute. The fourth upgrade is the smarter and the more powerful AI GIS. The Artificial Intelligence Technology System was released last year, and in this year, we have more enhancements on GeoAI and the model. As for the GeoAI, a lot of improvements have been made in processing and operators. As for model, we integrate the most industry's advanced models into our products to meet the requirements from the users. And these are the models we released last year. And in SuperMap GIS 10.9 2020, we provide more built-in models such as Mask, RCN, IPN, and Deep Level V3+, and all the highlighted in bold. Since different AI models are designed for various scenarios, users could choose the appropriate models based on their requirements and the characteristic of the data. We added 9 operators in geospatial machine learning operators. In the classification, we have newly added the map matching, logistic regression, graded boosting classification, decision tree classification, and naive based classification, and the SVM. And in the regression, we have the geosimulation, linear regression, and the decision tree regression, the three newly added operators. The cellular automata are discrete abstract computational systems that can be used to simulate various real-world processes. And this year, we introduced the cellular automata into GIS to do the simulation work. And by way of example, based on AI and the cellular automata, we can use the land use patterns of year 2001 and 2008 to simulate the land use changes between these two time periods. Let's check out the video. And the outcome of this simulation accuracy is 83%. Besides, with more training and samples, the results can be more accurate, and this could be very useful in land use planning. As for geospatial deep learning operators, object extraction in image analysis and spatial temporal analysis are newly added. We could train a CNN deep learning object detector based on the image data and samples to outline segmentation masks of objects in images. Let's say this, here is a good example. We use the object extraction to identify photovoltaic panels. As we see in this picture, due to the low image resolution, it was hard to identify each panel by using a semantic segmentation. As we see in the picture, it's all close to each other. Now we use the new algorithm and model, the instance segmentation as shown on the screen. The outline of all the photovoltaic panels are well extracted, and the results could be used for further applications. And based on the workflows we released last year, we provide a series of post-processing tools, including the nibble, shrink, expand, thin, and etc., to help to finish the job better. And this is a post-processing example about road extraction. As we see in this picture, after the binary classification, we still could use nibble, majority, and other post-processing tools to improve the result. Yeah, as we see in the final result, it's much better than previous ones. And I think it is great we use this the geoprocessing tools to perform the complete deep learning workflow in SuperMap GIS to make your work less artificial and more intelligent. The next upgrades I would like to talk with you is the cloud and the terminal integrated distributed geoprocessing tools. And this is a transition of the spatial data processing. In earlier years, we have to do the repetitive operations on desktop software, like endless mouse clicks to finish every step of the processing job. That means a lot of manual work to do and low efficient. Geoprocessing is offering a more easy to use method, which is to put different steps into workflows in order to perform multi-operation in an automated way. In SuperMap GIS, geoprocessing to provide tools and a cross-product framework from managing our GIS data to performing complicated tasks like the analysis functions. In the age of big data, the standalone mode is insufficient to serve such a huge amount of data with efficiency. So we introduced distributed geoprocessing tools this year to make the tedious work more efficient. Because of the same geoprocessing modeling structure, the SuperMap iServer WebGP modeling and the SuperMap iDesktop X GP modeling have the same predefined tools. As a result, the GP models could be shared and reused across SuperMap GIS products. For instance, we could export geoprocessing models from iDesktop X and then imported the geoprocessing models into a server. Then the GP tasks would run on the web immediately. Okay, the last one of the innovation is the fully upgraded one-click migration tools. Since 1990s, many software developers are moving from the Windows to Linux for more secure and reliable reasons, and it will become more common in this cloud age. Following the technology trends, in the year of 2000, SuperMap started the cross-platform developing work, and SuperMap GIS 5 is released as our first cross-platform product. As we all know, Microsoft Windows Linux operating systems were polar opposites for decades, but now even Microsoft begins to embrace Linux by releasing the Windows Subsystem for Linux tool, which supports various Linux operating systems running on Windows. We have tested microservices running on this WSL, and it is much faster than running on Windows. So maybe it's time to think about using cross-platform products. In the latest SuperMap GIS product system, we could see the majority of the products is capable of working on multiple operating systems like American Linux operating system or mobile devices. SuperMap GIS now is ready for the platform migration work. In terms of GIS applications migration, there are three aspects need to address: the data, map, and service, and each of them has a lot of work to consider. In the data, we have the vector and the grid. The data model has to be imported, and the map, the library, symbol library, and nodes, and the representations. And the service, we have to consider about the service and the caches. For the data migration, a series of workflows for the migration work combining with geoprocessing tools are provided, which obviously reduce the manual work and the time cost. This is a case, this is a real case in the surveys institute. And we also have built-in tools to do the map migration job, and all the styles, symbols, and other related properties of the map will be imported into SuperMap and remain unchanged. As for the service migration, and when you build up your service, are completely the same as I said in previous slides. After the migration, the works you finish will be perfectly preserved and you won't be stuck by the changing environment. And as server and edge are accessible by no matter a REST service or the tile package. The work you have done by the previous platform will be inherited by a SuperMap as server, and the users can continue to develop and publish new services by the SuperMap REST service. At last, let's make some summaries on highlights in SuperMap GIS 10i 2020. The technology evolution from BCC to BDC. The D is for the distributed GIS technology, and we have 6 key upgrades about blockchain technology, AI GIS, 3D GIS, ARGIS, geoprocessing tools, etc.